Now, we've seen what happens to the parent graphs when we increase the value of a. Now, let's look at what happens when we decrease the value of a. What do you think the graph will look like if we use an a value of a half? The new formula will be y equals half sine x and y equals half cosine x. The new graphs will look the same as the parent graphs, except that because a is equal to a half, all the y values will stretch by a factor of a half. But what does it mean to stretch a graph by a factor of a half? Well, the maximum point on the parent sine graph will move from 1 down to a half, and the minimum point on the parent graph will become negative a half. The x-intercepts will stay the same because 0 times a half is still just 0. As before, the sine graph curves between these points. This gives us the graph of y equals a half sine x. So when the a value in the formula is a half, we get a graph that is pulled towards the x-axis. If you compare this graph with the parent graph, you see that each point is half the distance away from the x-axis. Do you think we'll see the same thing happening to the cos graph? Let's have a look. The maximum points will be at a half, and the minimum point will be at a negative a half. The 0 values on the parent graph will stay the same on the new graph, and we get the graph of y equals a half cos x. So the a value of a half has the same effect on both the sine graph and the cosine graph. So far, we've tested 2 values for a to see what effect they have on the graph. You need to test some more values of a for yourselves. If we choose a positive a value less than 1, both the parent graphs are pulled towards the x-axis by a factor of a.